Problem number 2 reads, a boat can travel with a constant speed of 8 kilometers per hour in still water. In a river, the boat must head at an angle of 25 degrees upstream with respect to a line straight across the river in order to travel directly across the river. A, what is the velocity of the current? And B, what is the resultant velocity of the boat relative to shore? Let's first take a look at that boat. Our boat must head directly across this flowing river. In order to do so, we're told that the boat must head upstream. We're going to watch the motion of this boat in two parts. First, we will turn the current off and watch the motion of the boat in still water. Then we will turn the motor of the boat off and watch the motion of the boat as it simply floats with the current. Looking at the motion in still water, it would look like that, and now if we turn the motor of the boat off, the boat would simply ride with the current like that. Both motions together would look like this. Here you see a vector representing the velocity of the boat in still water of magnitude 8 kilometers per hour and angled at 25 degrees upstream. When the velocity of the current is added to the velocity of the boat in still water, it produces the resultant velocity of the boat with respect to the shore. We are asked to find this resultant velocity and also the velocity of the current. All right, that is our problem. Why don't you try to solve that problem before watching its solution? Here is that same vector diagram. I've labeled the velocity of the current v sub c and the resultant velocity with respect to the shore v sub r. Notice that the diagram forms a right triangle with hypotenuse 8 kilometers per hour and angle 25 degrees. In part A, we're asked to find v sub c, the velocity of the current, and v sub c from our right triangle would simply be the hypotenuse 8 kilometers per hour multiplied by the sine of 25 degrees. And if you work that out, you will get 3.38 kilometers per hour. So that is the magnitude of the velocity of the current. Its direction is just the direction shown in the diagram. In part B, we're asked to find v sub r. V sub r we can also find from trigonometric relationships. It's equal to 8 kilometers per hour multiplied by the cosine of 25 degrees. We're looking for the side adjacent to that angle now. This gives you a value of 7.25 kilometers per hour. So that is the magnitude of v sub r. Its direction, of course, is just directly across the river. You could also find v sub r from the Pythagorean theorem. Once you've found two sides of this triangle, you could find the third by means of the Pythagorean theorem. All right, that is our solution then to problem number 2. Problem number 3 reads, rain falls straight down with a speed of 10 meters per second. If a car is traveling along a level road with a constant speed of 20 meters per second, what angle with